Okay, so let's take a look at this 2.3 factoring polynomials. This is just a recap from last year. From grade 10, you had to know all the types of factoring. So this is just a recap of that. If you don't know how to factor, this is going to be a good little session for you. So you have to know how to factor a common factor. You have to do product sum integer for simple trinomials. You have to know how to factor complex trinomials. And then of course there are those perfect square trinomials and also difference of squares that have shortcuts to factor. So let's take a look at this one first. It says common factors, so factor the following. So these are just regular common factor questions. And if you take a look at the first one here, between those two items, 5x minus 50, between both, you can factor out a common factor. The greatest common factor is 5. So we can factor out a 5, and then what remains? Well, 5x divided by 5 is just x, and negative 50 divided by 5 is negative 10. And so this is just the final answer right here, 5 times x minus 10. Of course, if you re-expand here, 5 times x is 5x, 5 times negative 10 is negative 50. This obviously is going to help you to put something in standard form into factored form. We have to know how to factor in order to figure out our x-intercepts or our zeros. So let's take a look at this one. And between these two things, the greatest common factor is in fact 3y. So this says 3y squared plus 9y. The greatest common factor is 3y. And if I factor out a 3y from both of those items, remember it's from both, 3y squared divided by 3y is just y. And 9y divided by 3y is just positive 3. And again, if I re-expand this, 3y times that will give me 3y squared. 3y times 3 is 9y. So in fact, this is correct. And that's all we can factor out. For the last one here, it says 4a cubed minus 2a squared plus 8a. And the greatest common factor between all of those things, well, between the numbers, the greatest common factor is a 2 that I can factor out from all of those. And then the greatest common factor between the a's is just an a, because this one only has one a to give. So 2a is the greatest common factor between all those three items. 4a cubed divided by 2a is 2a squared, and 2a squared divided by 2a is negative a, and 8a divided by 2a is positive 4. And if you re-expand this in, of course, that is going to give you that. Now, I'm going to say this is the final answer for now, but in fact, this part here, you're going to have to figure out if that is factorable further, because this is actually a complex trinomial. You have 2a squared minus a plus 4. That's a complex trinomial, and we can factor complex trinomials using decomposition, and I'm not sure if this is factorable or not right now until I show you how to do that. So we can come back here to check to see if we can factor that further. But we'll continue on to example 2. Example 2 says, factor simple trinomials using product sum integer rule. So it says factor the following trinomials. So these are simple trinomials because in front of the x squareds, there's just a 1. So there's a 1 in front of all these x squared, so they're simple trinomials. So we can go right to the answer if these things are factorable. A trinomial will come from two binomials being multiplied by each other. So the first rule, we have to still apply that. Is there a common factor between these things? And the answer is no. X squared plus 7x plus 12. There's no common factor between all three items. But it is a simple trinomial, so we're going to use product sum integer rule from last year. So just as a reminder, the product of this thing is the last number, which is 12. The sum of this thing is the middle number, which is positive 7. So you're looking for two numbers that multiply to 12 but add to 7. The two numbers are 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. So the first bracket will have x plus 3, and the second bracket will have x plus 4. And this is my final answer. If you re-expanded this from 2.1, 2.2, you would end up with that trinomial there. The next one, x squared minus 8x plus 15. The first thing, again, I check for is a common factor. There's no common factor between all three items. So now that this is a simple trinomial, then I'm going to factor this using product sum integer rule. How do I know it's a simple trinomial? There's a 1 in front of the x squared, no other number. The product of this thing is 15. The sum of this thing, be careful, is negative 8. So two numbers that multiply to positive 15 but add to negative 8. Again, if you're ever stuck, you can list the factors of 15. There's 1 times 15 and there's 3 times 5. Those are the only things that multiply to 15. So then I have to add to negative 8 though. So this would never add to negative 8. This here though has a possibility only if both are negative. Negative 3 and negative 5. Negative 3 times negative 5 is positive 15, and when you add them, it's negative 8. So the first bracket will have x minus 3, and the second bracket will have x minus 5. And this will be the final answer. Again, if you expanded that, re-expanded that, that will be the trinomial you'll end up with. The final one here says x squared plus 10x minus 56. So again, I checked for a common factor. There's no common factor. I know it's a simple trinomial because there's a 1 in front of the x squared, so I should be able to go straight to the answer if this is factorable. So I'm going to use product sum integer rule, and the product of this thing is negative 56. The sum of this thing is 10, and the two integers I'm looking for, again, if you are ever stuck, you have to look at what multiplies to 56. Of course, there is 1 times 56. There is going to be 2 times 28. There's no 3. Is there a 4? Yes, there is 4 times 14. And it kind of looks like I found it already. So if you think you found it already, you can kind of stop right there. But there are more. This would never add to 10, neither would this. But this already has a possibility of adding to 10. You have to multiply to negative 56, so only one of them could be negative. And so the correct answer would be if you had negative 4 and positive 14. Negative 4 times 14 is this, but negative 4 plus 14 is positive 10. I don't have to list any more because I already found them. So those are two integers. So my first bracket's going to have x minus 4. The second bracket's going to have x plus 14. And this is my final answer. If I re-expanded that, I would end up with that trinomial there. So you have to know how to, the first step is factor out a common factor always. Sometimes there is a common factor when you're dealing with trinomials, like there was in the first one. Then B, factoring using product sum integer rule of simple trinomials. Now, the third one, factoring complex trinomials using decomposition. There actually is a different method called the X method or crisscross method. If you'd like to learn that, I would check crisscross method on YouTube, and there's actually a quick way of factoring these things without using decomposition, but that's another thing you would have to learn, and you have to get good at. So factoring using decomposition. So factor these following questions here. So the first question here is 12x squared plus 5x minus 2. Again, the first thing I check for is a common factor, and there is no common factor there. So the next thing I do is, what am I dealing with? This is a complex trinomial because I have a number other than 1 in front of the x squared. It's a 12. So right away, I know I have to use decomposition. It's complex. So you cannot go right to the answer. There's no product sum integer rule for that one. You have to use decomposition, which is leaving the first and the last terms the same and breaking up the middle term. Hopefully this brings back some memories. And then you would use product of AC, sum, and integer. Now the product of AC, okay, is A is the number in front of the x squared, C is the last number, the constant. Again, leave the first and last terms the same, and you're going to break up this middle term into two terms that still add to 5. Now you're going to break it up appropriately. There's a way of breaking it up, and it's using this method here. Product of AC is 12 times negative 2, which is negative 24. The sum is positive 5. So what do I break these middle term up to? I break it up into two numbers that multiply to negative 24 but add to 5. Again, if you're stuck, you'll list the products of 24. There's 1 times 24. there's 2 times 12, there's 3 times 8, okay, there's 4 times 6, and that's it. 5 times nothing, then there's 6 times 4, so it's the same thing. So this would never add up to 5, neither would that, neither would that. The only possibility are these two somehow. One of them have to be negative because they're multiplying to negative 24, so the correct answer is actually negative 3 and positive 8. Negative 3 times positive 8 is that, negative 3 plus 8 is 5. So I can break up the middle term into negative 3x and positive 8x, okay? Because those are the two numbers. Now, using decomposition, then we have to group the first two terms and group the second two terms and factor using common factors. So this is factoring by grouping. So grouping the first two terms, I can factor out between these two things a 3x. And if I factor out a 3x from there, I'm left with 4x. And this divided by 3x is minus 1. And then between these two things, I can factor out a 2. So I'll factor out a positive 2. And this divided by 2 is 4x. And this divided by 2 is negative 1. How do you know that you're doing this right? Well, you know that you're doing this right because the two brackets should always look identical. Now you have two items here. You have this stuff plus this stuff. Now between those two things, what is in common? What's in common is the 4x minus 1. And if I divide out the 4x minus 1 from the first thing, I'm just left with 3x. And if I divide out the 4x minus 1 from the second thing, I'm just left with plus 2. So this is my final answer. And again, if I re-expand this times this, I will end up with this trinomial. Okay? So reiterate what happened here. Again, complex trinomial, you can't go right to the answer. You have to use decomposition to break up the middle term. After you break up the middle term, you factor by grouping. And when you're factoring by grouping, your two brackets should always look identical, and you could always factor out the bracket from both terms and tell me what's left at the end.